we're all sitting here. We're going to paint some pretty little trees. All right. Good morning, good afternoon, or good evening, whenever you're watching this video. This is lesson 78. Okay, we're going to learn the difference of two squares. All right, so if you go ahead and show the screen here. All right, now we've learned the difference of two squares, but we're just going to be factoring quadratic equations. So we've got quadratic equations, which means that it's degree 2, or we see that exponent there, the highest exponent, as you see here. Let's see. Can you see my mouse there on the screen?
Mm-hmm. Yeah.
All right, so we see that exponent right there is 2. I might be able, let's try this here. I think I might be able to circle it. Oh goodness, I just erased it. All right, let's try this again. Oh, that's why. Okay, let's try this again. All right, kind of hides it. You all know inside there that exponent's 2, so that tells us it's a quadratic equation. All right, so we're solving for that quadratic equation. Well, the first thing we want to do is try to factor. Now this says factor. What we often forget is to look for the greatest common factor. All right, so we look at 9x squared and 25. Is there a common factor? No, there's not. Okay, so what we're going to do is we're going to, we should recognize that it's a difference of two squares. So we see the format when we do this, 9x squared. What times itself gives me 9x squared? Give you a second to think about that. Yes, you're right. All right, now while I'm talking, Chloe, you can show me. All right, when I go to change the math problem on the screen, you can do that. All right, yeah, 9x squared. What times itself gives me 9x squared? 3x. 3x times 3x gives me 9x squared. Now what times itself is 25? 5. Yes, that's right. Okay, so 5 times 5 is 25. So we look at this. All right, we put in the format. All right, so we would have, go ahead and look at the screen there. You've got 3x plus 5 times 3x minus 5. All right, we see that since 3x times itself, 3x times 3x gives me 9x squared. 5 times negative 5 gives me negative 25 there. We factored this first, 3x plus 5, 3x minus 5. All right, now the zero product property. Okay, the zero product property. You can go ahead and go back to me, Chloe. All right, zero product property says that each factor we can set equal to 0, because if one factor is equal to 0 because we're multiplying, then the whole thing's going to be equal to 0. All right, so we set this up, okay? There you go. 3x plus 5 equals 0, and we're going to set 3x minus 5 equals 0. All right, then we're going to solve. All right, I'll do my best with the Mimeo on my screen. All right, so we solve this. So the first thing, inverse function, since we're adding 5, we want to subtract 5 from both sides. Just like that. Okay, then we get 3x is equal to negative 5. What's the next step we do? Well, to undo the multiplication, we would divide by 3. Okay, divide by 3. So one of my answers, or one of my roots, a lot of times they'll ask you for roots or x-intercepts. Know that they're talking about the same thing. All right, so one of the answers will be negative 5/3. And I know you guys are capable, you can go ahead and look at the screen here, of solving the other part. So we'd add 5 to both sides, divide by 3, and we get 5/3. So my solutions to this would be negative 5/3 and positive 5/3. And if we plug those back in, we'd see that both of those solutions would give me 0. All right, let's go ahead and go on to the next problem. All right, now you're looking at this. 7x squared is equal to 63. All right, look at that equation. Hey, what's different from this one than what you saw before? Well, this one, the previous one, if we look back at it, we started off with both terms on one side of the equation. So we will want to do the same thing with this one. Okay, get both terms on one side of the equation. So what are we going to do? We're going to subtract 63. All right, so we get 7x squared minus 63. Now, go ahead and look at me, Chloe. What did I say to look for first? Did we look to factor right now, or was there something we looked for first? Yes, there was something that we looked to first, and that was the greatest common factor. What is the greatest common factor between 7x squared and 63? Do you know it? Chloe's looking at me like I have no idea. The common factor is 7, okay? Hopefully y'all recognize that there, but it has a common factor of 7. So what we're going to do is we're going to factor that out. Okay, factor out the 7. Now, x squared minus 9, can I factor that? Is that the difference of two squares? And hopefully you said yes. X times x, go ahead and look at the screen. X times x would give me x squared, and 3 times 3 would give me 9. So I can factor that, and that would factor to what? That would factor to, you can keep it on the screen, that would factor to x plus 3 and x minus 3. All right, so we look at there. All right, now we have those factors. Now what we're going to do with those factors is, remember the zero product property. Oh, am I calling it the right thing? I'm sometimes bad at that. Yeah, okay, zero product property says that we can take both those factors with the variables and set them equal to 0. So we have x plus 3 is equal to 0, and x minus 3 equals 0. Now most of you can solve that in your head, and I encourage you. Okay, I encourage you that if you can solve it in your head, go ahead and do it. All right, but those more complex ones that have coefficients in front of the x, you're going to have to, those you may need to solve by an equation. All right, so you do that in your head. Did you already do it? Good job. Okay, look at the solution. The roots, and remember they call them the roots because this is where it's going to cross that, that x-axis. All right, the roots are -3 and 3. All right, let's go ahead and go on to the next problem. All right, solving a cubic equation with a quadratic factor. All right, cubic. So we've got an equation. It's called a cubic equation because the degree is 3. All right, we see that little 3 up here. Okay, that tells us the degree. That means it's a cubic equation. All right, you've got 10x. All right, oh, I skipped ahead. All right, we want to remember the first thing we want to do is look for a greatest common factor. All right, and that greatest common factor would be 10x, so I factor that out. Now, x squared minus 1. You can go ahead and look at me here, Chloe. X squared minus 1, is that the difference of two squares? Well, I know x times x is x squared. 1 times 1 is itself, okay? So it is the difference of two squares. Go and look at the screen. We factor that, it would factor to x plus 1, x minus 1. Remember the difference of two squares, the middle term cancels out. All right, now we've got to be careful here. We actually have this as 3 factors, as you can see. You've got the factor 10x, you've got the factor x plus 1, and you've got the factor x minus 1. Once again, we want to use the zero product property rule, and we want to set each one of those factors with a variable equal to 0. So 10x equals 0, x plus 1 equals 0, and x minus 1 equals 0. Now, I think that all of you can solve this on your own. 10 times what gives me 0? Chloe, can you answer that? 10 times what equals 0? Yes. Okay, so one value would be 0. X plus 1 equals 0. What value for x would that be? Yes. Okay, it would be -1. And x minus 1 equals 0, also 1. So we see the roots, or the solutions, or the x-intercepts. I'll try to say that a lot because an ACT will ask it 3 different ways. But our roots are 0, -1, 1. Meaning if we were to graph this out, go ahead and look at me here, Chloe. Meaning if we were to graph this, and hopefully we can get a little bit of practice on our Algebra app where we can look at this, but if we were to graph this out, it would intersect in 3 different places. All right, on to the next problem. Okay, solving a quartic equation. All right, never saw one of those before. All right, but a quartic equation is where we have a power of 4. Okay, we call it quartic. We mostly work with cubic and squares and quadratic equations, okay, but we have a quartic equation. Is it the difference of two squares? Well, what times itself gives me x to the 4th? X squared. And we know that 16 is a perfect square, so we can factor this. Okay, x squared plus 4, x squared minus 4. All right, now, hopefully you've got in a good habit here. What do we do next? Well, we set both those equations equal to 0. Oh, Okay, I missed it. Okay, x squared minus 4 there, we have the difference of two squares again. So we can factor that one down to x plus 2, x minus 2. Remember, when we're looking for the difference of two squares, there has to be that subtraction sign in between. We look at this, x squared plus 4, that one is not the difference of two squares. Okay, have to have that subtraction sign. All right, so we're going to set all these equal to 0. Now these two right here, x plus 2 and x minus 2, you can probably solve these in your head. The solution for this would be negative 2. The solution for this would be 2. But now what about x squared plus 4 equals 0? Is there a real value that I can put in for x squared that would satisfy the equation? And the answer is no. All right, but we're going to solve this to see if there's some complex solutions that comes up. So we'll subtract 4 from both sides. All right, once we do that, whoa, look at that 4. All right, so we get x squared. This is really taking my art talents here. All right, x squared is equal to negative 4. All right, what do we do next? How do we solve for x? All right, yes, we would take the square root. All right, remember when we take the square root, we have to do plus or minus in front of it because the positive and the negative value would work. Okay, plus or minus the square root of negative 4. Now, I'm happy with that square root. That's pretty nice. All right, what is the square root of negative 4? Huh? All right, it's not a real number. If you remember, the square root of negative 1 is I. So we're going to take the negative out. Go ahead and look back at the screen, Chloe. Take the negative out. So we get x equals plus or minus. Okay, take the I out. Then we would just, that's like taking the square root of negative 1 out. We have square root of 4 left over. What is the square root of 4? Hopefully you all are answering 2. So we write that number first. We write 2 first. We get x is equal to plus or minus 2i. Okay, so we have two complex solutions, or two imaginary solutions, and two real solutions, negative 2 and positive 2. All right, example number 4. Now, go ahead, you can look at me here, Chloe. All right, example number 4. Now, I've decided this one is just really complex, and we know some of the lessons in this Algebra 2 book are pretty tough. So I'm actually going to skip by this. If we come across one in homework, I may go over it. Maybe it'll be a bonus or something, but I'm not going to require you to factor these more complex functions. All right, so on to example number 5. Okay, application. All right, now anytime we're talking about quadratic equations, we're talking about motion. And I'll try to show that video. I actually broke it down where Noah threw that ball, and we saw that the path of the football was a quadratic equation. This would be one of those type of equations. Anytime you have something in motion, you can use a quadratic equation. All right, let's go ahead and read this together. You can read it on the screen there, or if you've got your books open to lesson 78, you can read it that way. All right, the height of a free-falling object, neglecting air resistance, is given by the following equation. All right, where h, and you see the little subscript 0, is the initial height in meters, and v with the subscript 0 is initial velocity. So the h and the little o or little 0 there stands for what was the initial height? Where did it start from? Okay, and the v with the 0 is the initial velocity. What did it start? What speed did it start at? Okay, h of t is the height in meters at time t seconds. So h would be, for instance, after 3 seconds, how high is it? After 4 seconds, how high is it? All right, here's a question. How long does it take for an object to hit the ground after it is dropped from a height of 40 meters? Okay, now, all right, we're looking at this problem. Okay, ask yourself this, or what is that 40? Where does that go? That's a variable. Okay, drop from a height of 40. Okay, is that the h of t, the height after so many seconds? Do we know how many seconds that took? No. Is it initial velocity? Is that how fast it started? Or is that the initial height? Yes, it's the initial height. So that 40 is going to replace the h0. All right, now what about the initial velocity? Okay, initial velocity, it talks about, okay, after it is dropped. Now, if I drop something, okay, does it have any initial velocity? What's the speed it's starting with? If it's not moving and I drop it, the initial velocity would actually be 0. Okay, so we plug that in. All right, so we'll look at this equation. Go ahead and look at the television there. Okay, all right, now we went ahead and filled it in. But we think about this, we want to know, okay, how long it'll take to hit the ground. So we see this h of t here. Well, when it hits the ground, what is the height when it hits the ground? How high is it? Well, if it hits the ground, it's at 0. So that's why we put the 0 in there. All right, now 0t, we can clean that up. We can just take that out, clean that up a little bit. All right, now, what we want to do next is, if we're trying to factor this, see that negative in front of there? We don't ever want that coefficient to be negative. So what can I do to make it positive? Well, I can multiply both sides by a -1. Hey, Jace. All right, when we multiply both sides by a -1, what we would get is 0 equals 4.9 t squared minus 40. All right, now, next step we would do is we want to get rid of the decimal. Now, what would I multiply both sides by to get the decimal? Okay, to make this whole numbers. Well, I multiply it by 10. All right, we multiply it by 10, we get 0 equals the following equation. All right, now, is that the difference of two squares? And you should look at it and say yes. Okay, 49t squared, 7t times, don't yawn, Chloe, this is exciting. All right, 7t times 7t is 49t squared, and 20 times 20 is 400. All right, so we see, yes, this factors to 7t plus 20 and 7t minus 20. All right, so then we set both those equal to 0. Now we get a time is equal to 20 over 7 or a time is equal to 20 over positive 20 over 7. Now if we look at those, okay, positive, you can go ahead and put this to me. All right, can you have a negative time? Well, you can't have a negative time. Okay, so go back to the screen. Anytime we get this, when we're using the application problem, if you get a negative time, we're just going to cross that out. Okay, we don't need to use that. Negative time doesn't exist. Okay, so we'll mark that out. So the one we're going to use is 20 equals 20 over 7, and we can convert that to a decimal in our calculator, or keep it as a fraction. Usually we'll convert it, and that tells us how many seconds it would take that ball to hit the ground. All right. Are you on me? Mm-hmm. All right, well, hopefully this lesson is clear. Feel free to comment on this and ask any questions that you have. If you could, try not to put those comments on YouTube. I don't think that's necessary. But if you would put your comments on Google Classroom, if something's hard for you to understand, or if you'd like me to go back over this during the live sessions, I'd be more than happy to do it. All right, hopefully you're having a great day. Hopefully this lesson went well for you, and we'll talk to you later. Bye.